Hi everyone, my name is Thomas Kim. Today is February 13th, 2021. This is my 78th episode about the programming language C++ 20 standard. In this episode, I was about to discuss keyword auto L-value reference, auto forwarding reference, decltype auto, about these things, but I changed my mind. Suppose we declare a function template, type name t, for example void tell type info t a. We created a simple function. Now in this function std forward t a std forward decltype a. These two expressions is exactly the same. These two expressions is exactly the same. T can never ever be R-value reference. T can be either L-value reference or non-reference type. For example, integer L-value reference, constant integer L-value reference, or int constant int. In this case, constant is meaningless, so T can never be R-value reference. T can be either L-value reference, such as int L-value reference, constant int L-value reference, or non-reference type. This is not reference, but the type of A can be L-value reference, R-value reference, non-reference type, such as integer L-value reference, constant integer L-value reference, integer R-value reference, or non-type reference, such as int. However, if we apply std forward t a always ends up std forward decltype a. If t is integer reference, then a is integer reference. So std forward integer reference a, it becomes integer reference. This is t. Okay, t. Then a is integer reference. This is t coming from here. This is t. A is integer reference. Then reference collapsing rule says integer reference. Now t is int, a is integer R-value reference, then std forward int a. Int represent the type of t. Int, the type of a is R-value reference. Int, then it ends up int R-value reference. In this case, std forward decltype a is integer reference, so it becomes integer reference like this. Integer reference. So integer reference, this is integer reference. This case is TA. This case is decltype AA. The result is the same. Now, std forward decltype A. In this case, A's type is R-value reference. So, std forward int R-value reference A, int R-value reference A is R-value reference. So, int R-value reference. In this statement, std forward int is the type of t. So, std forward A is integer R-value reference. std forward decltype A ends up integer R-value reference. This statement is exactly the same, even though the type of t, the type of A are different. In this case, the type of t, the type of A are the same. So this statement ends up integer L-value reference. In this case, the type of t is int, the type of A is integer reference. std forward t A, std forward decltype A ends up integer R-value reference and integer R-value reference. The conclusion is that std forward t A is identical to std forward decltype A. I will define some terminology. In this syntax, T is template parameter, A is function parameter variable. At this point, this is called parameter declaration. This is called template parameter list. At this point, T is forwarding reference. T is a forwarding reference. In the function body, T is no longer forwarding reference. The type of T is already determined by the compiler. In the function body, T can be either L-value reference or non-reference type. For example, L-value reference, int L-value reference. Non-reference means int or double. These are not reference. So non-reference type. I made a big mistake here. This is wrong. This A comes from here. A can never ever be a non-reference type. A with 2 ampersand in front. A always ends up either L value reference or R value reference. A always ends up either L value reference or R value reference. T can never be R value reference. T always ends up either L value reference or non-reference type. And with this declaration, A can never be non-reference type. A can never be non-reference type, such as int or double. With this syntax, A becomes either L value reference or R value reference. A always ends up as a reference type. In the same manner, or ampersand A always ends up as an L value reference. Or A always ends up either an L value reference or R value reference. Or A some initialization, A always ends up non-reference type. With this syntax, A can be pointer type in case of array and function. In case of decltype or A some initialization, of course we need some initialization here too. In case of decltype or the type of A can be non-reference type, such as int, double, L value reference, such as int reference, double reference, R value reference, such as int R value reference, double reference. Int A5 or B A legal syntax or C5 illegal syntax. 5 does not have memory yet, and L value reference does not have ownership. So this syntax fails, but constant or D5 is valid. The type of D is constant int reference. In C++, constant integer reference D5 is valid due to historical reason. But please note that or E5 is valid. The type of E is integer R value reference. R value reference has ownership. R value reference creates memory for pure R value 5. When E goes off, its declared block, the memory for 5 is destroyed. Then constant auto D5 valid auto E5 valid. It becomes constant int reference D5. It becomes integer R value reference D5. What is the difference? D equals 6 invalid. E equals 7 valid. The memory allocated for 5 in this syntax we can modify the value of E because the raison d'etre of R value reference is to recycle R value. Here 5 is R value. We can recycle the memory for R value using this syntax. Now let me explain why I use this syntax. Auto fun, auto x, auto whenever I create lambda, I use this syntax. Let's see why. If I create auto fun, auto x, auto y, int x 2, y 3, fun x, y is valid syntax, or constant int L value reference xx, x, constant integer L value reference yy, y, fun xx, yy is still valid because in this case can map to constant xx, auto y, constant integer reference yy, both are valid syntax, but fun 2, 3 is invalid. Two cannot bind with this syntax. 3 cannot bind with this syntax. Here, we cannot pass pure R value 2, pure R value 3 to this function because auto x2, auto y3 are invalid syntax. However, with this definition, fun x, y valid with this syntax. X is L value, y is L value because auto A, X, auto B, Y are valid syntax. where x and y are L value. Also, func C with constant L value reference XX, YY is also valid. Now, func 23 is also valid because this auto X can bind to this auto Y can bind with 3. If we pass pure R values to this lambda, we can use this X and Y. We can modify the value of X, the value of Y with this syntax. And when this function goes off, the memory port 2 R value reference X, the memory port 3 R value reference Y is destroyed properly. Last but not least, we can recycle the memory port 2 and 3 here with decltype auto. With this return type specification, if context pair SED is R value reference B decltype X. Now in this block, we can recycle the memory of X. X is R value reference. Then we return std move X because X is this temporary pure R values memory. We recycle this memory. We recycle the memory for pure R value 2 is R value. Else if context pair, I copy this, paste. If Y is pure R value, then we recycle the memory of Y, return std move Y. Else return X plus Y. We are creating a new instance. This is so-called X value. I created this video to answer Mr. Triangle's question. I have 2 questions. I know your code is just for explaining the concept, but I still wonder if my thought is correct. The specialization of evaluation function for SDD array, I thought it would be template, type name, t size, class container type, etc. I think the type name t is contained type in the array, so the second parameter should be size of the returned array. I didn't understand it. Secondly, std forward func types func should be std forward decltype func because func types can never ever be R value reference. Thank you. I really like this algorithm you presented. I answered the second question in this episode. About the first question, template type name t size t class container type, I will answer in my next episode. Thank you very much, Mr. Triangles. Mr. Triangles, you are awesome. I have no word but to say awesome. Your comments motivated me to create this video. Mr. Balu Nit, unable to download the source code. Double-click this link. In this video, show more. If you double-click, you cannot download. In such case, right-click, copy link address, then paste it here. Then you should be able to download successfully. When I create this video, I haven't used SYCL and I posted it in the wrong place. So if you fail to download, right-click, copy link address, then paste it here, hit enter. Thank you very much, Mr. Balloonit. Because you left this message, other audience can also download the source code from my older videos. Because you left this question, other audience can also benefit from it. Thank you very much, Mr. Balloonit. Dax, awesome video. Greatly appreciate you doing this. I always been a C guy, and learning C++ metaprogramming stuff is a pain. And these videos saved me a lot of time. Thanks, Thomas. Thank you very much, Mr. Dax. In near future, I will create a directory video about how to take best advantage of my playlist. Thank you very much, Mr. Dax. Carrot, I absolutely love your videos. Your YouTube channel is a hidden gem for modern C++. It deserves more attention. Thank you very much, Mr. Carrot. Your short comments is the driving force with which I can maintain this channel. Were it not for your encouraging message, I would stop this channel or create videos for my own consumption. Thank you very much, Mr. Carrot. You are not wasting your time. Your videos are appreciated by your audience. Thank you very much, Mr. Harrison Marshall. Daniel Fragoso. Hello, Thomas. I would like to know if you are willing to help me with a crypto project. Thank you very much, Mr. Daniel, but I don't accept any kind of business proposal. I am already too much busy with my own business. Thank you for your offer.